Ciao, ciao Matteo, welcome back.
Hello, Luca. Welcome back. And we are back on the Banter with
Wow.
a recorded episode because when you're seeing this, I will be at JSConf in Baltimore, in Maryland, on the Chesapeake Bay. It's been a phenomenal resort. So we are recording this early. So this is going to go out when I'm traveling, so I will not be able to record this next week.
And I will be at Cabo San Lucas at the Four Seasons. Oh, no, sorry. I will be in Milan. For
Luca
work.
will be in Milan. So sorry, guys. We are not going to be live this time. So,
but we are just last week coming off from a fantastic episode with our close friend Feroz. Beautiful episode.
Yes. Oh gosh.
We should get him back, by the way. And today we are talking about drum roll. Python and Node meets in what? Splash. But it's not a joke, this one. It's reality. And Matteo, but let's start with something, because I don't know how many they really know it, but what is ASGI before people
ASGI is a phenomenal acronym that we didn't even translate in the
description.
That's in the description. So I should have probably do something. Is a synchronous server gateway interface, which is a successor of WSGI, okay, which is web server gateway interface, okay, and which is both of them are standard Python specifications that defines how web servers and web applications communicate, providing a consistent way for servers to send requests to applications and receive responses. I'm absolutely reading it from AI, okay? So the key part here is, for all of you that are familiar with Node.js, it's kind of similar of the request-response pattern of Node to some extent, okay? WSGI is synchronous, while ASGI, as the name says, is asynchronous.
Wow, I feel that we just discovered the warm water, but
no, Luca, boiled potatoes.
I kind of like them.
I know. Okay, somebody likes them mashed though. Anyway, so what is critical for this? So this system in Python, okay, but they are present in Python, in Ruby. It's a similar system, okay. It standardizes how the application, how frameworks, how web servers talks to frameworks, talks to application. So everything is connected together, okay? Mm-hmm. It's a standard way, okay? So anybody can take the spec and wrap a Python interpreter and start running requests through it. Pretty amazing.
Cool. But let's maybe jump a little bit into the story, right?
Yeah.
So once upon a time there was Node.
In a galaxy far, far away?
In a galaxy far, far away there was also Python.
Yeah.
And then big data and AI and all those kind of things came to our lives. So we basically traveled to Mars, and there was a new colony, the new generation of AI-driven application. And where is actually why? Let's tell to everyone, why did we put Python into that?
Okay,
that
so
is
there is a key
Node.js
point.
application server.
There is a key point that is important to note. Okay, 2 reasons. Okay, the first big one is the emergence of AI systems. Okay, there is this impression. Okay, that anything related to AI should be written in Python.
Why?
Because Python is the language of AI.
No, it was the language of data, they said before.
Now becomes the language of AI.
Tomorrow?
I think it will go back to be the language of data, but that's my read. But it's I'm telling about the market right now is the language of AI, And there are plenty of AI-based software that you can, AI-related software that are becoming so widespread and so common out there that it's great.
Yeah, because I left the big data world with AI being the core language of any data playbook, right? Together with Scala, but mostly Python. So, okay, but let's maybe tell everyone, well, a small kind of like flashback. We released a few months ago PHP into VAT because we believe that the headless world needed a way to bridge from WordPress or Symfony or anything Drupal to Node, the language of modern web applications. Can we say
well,
that?
everybody needs to write a web app these days, and people wants to write them in Node.js. Like the common way to build them right now is with Node.js.
No, but I'm only building a front end for my application. Why do I need Node?
This is a good question, okay? The biggest reason is the job market, okay? There is essentially a lot of things right now I'm standardized on a React plus Node.js combo that is essentially dominating companies and everything, more or less. And that's it.
No, but I don't have Node in my stack. I just have React or Angular. I don't have Node. I have Java and React and Angular. Where is Node in this equation?
Oh, this is a fun story, okay? If you ever are using one of those modern full stack framework, and I stress the full stack, okay, you actually are running Node on the server. You need Node.js to be able to have user and render your server side components. One of
so
the
I
things,
do have Node.
So you do have Node, yes. You
Oh,
have Node.
So even if I
Node.
build my fast API backend because I love Python, but I have my React front end or my next front end,
you
I have
Node. You have a Node system running anyway, anytime. As everybody, as I tell everybody, says, "Oh, we are not running Node." Okay, how are you building your front ends? And the answer is either React, Vue, Next, some
Svelte.
new Svelte kit. Svelte is still okay, can be a SPA, okay? But they all start saying all these same things, and that is pretty bad overall. All of them requires Node.js on the server to render the thing, okay?
And okay, so we can say one thing today, that Node is there. It's just that you don't see it. But
it's worse. It's worse than that. Node was sneaked in by some developers because they needed to get the job done, and you probably do not realize you have Node.js.
Okay, and so, but why kind of like Python had this kind of like so dominant position in the AI data and space, and why does it need to be integrated with Node? Tell me something. Today I'm asking you a question because I know that in the future there will be one episode where you are going to do the opposite and drill me, so I'm taking advantage.
Repeat me the question.
Repeat the question. So, but can you please elaborate why Python has been so dominant in the AI and data science world?
Easy.
And why today we need to bridge that gap into Node?
Easy. Okay, the reason is a lot of data scientists have prototyped their LLM system in the language that they knew, Python. Okay, this is okay. This is great. Okay, and because of that, there is a maturity on the frameworks, the tooling, and everything that is essentially unmatched. Okay, Node.js-based systems come close, but they are always like a few months behind the bleeding edge of that is being produced by AI scientists. Okay.
Okay.
So because of that, there is this feeling that if you want to be at the tip of the edge, you need to use Python. Okay, and therefore a lot of CTOs have sent a mandate to use Python everywhere for AI systems. Now.
Oh, okay, got it. So it's kind of like where you see it is a huge misunderstanding also on not a misunderstanding, misalignment between what is needed and
Most
what it should be
of
done.
AI applications, okay, do not need Python. Okay.
Okay.
They do nothing related to data or science or anything. In fact, if you are just calling API endpoints like LLMs and using long-running connections, like token streaming down, you are probably better served by a language like Node.js, by a runtime like Node.js, or Go, Rust, okay, than Python, because Python still has some async await has been built in later on. It has a little bit of quirks regarding that, and
So,
it's a little
but
bit slower than the alternatives, essentially.
so Matteo, let's try to jump into a little bit the reason what took us. So why did we build this thing?
So at the beginning of the year, we were starting chatting with a lot of companies, building integrated Node.js plus Python systems for data analysis, data science, AI, all sorts of things. Typically, it's experiments being done in Python by some data scientists, okay, that want to keep maintaining the experiments in Python. They needed to be wrapped and operationalized by a team of engineers. And also, those same teams of engineers needed to expose them as API, as on the web, okay, for use and consumption through modern frontends. So here we are, and we've seen this pattern everywhere.
And so basically, everything that we did in VAT till now was serving the purpose of bridging the gap between building data intense application or whatever, connecting to those playbooks or models and serving the modern web in the fastest way and most reliable way possible without having to create this horde of microservices that they just clutter your network.
The horde of microservices.
But let's maybe tell everyone a little bit how we went from nothing to have it running with a tiny small overhead and actually running sometimes even faster than you would in some other places. So let's maybe kind of like start from the foundations of what we build.
I am reporting what I studied. Okay, the actual thing was built by Steven Bellinger, a friend of ours and a phenomenal engineer. Hi, Steven. Hello. Okay.
That it works for us. It's not
and
just
it works for us. So it works for us. So I just putting credit where credit is due. Okay. It is the design.
Platformatic engineering.
It is the design. Okay. So Python, okay, is a native system. Okay. Blah blah blah. Okay. So it needs to be compiled. Native add-on. Okay. We need to have a native add-on to load Python. So we use NAPI-RS to build a native add-on using Rust. Okay. To wrap Python. Okay. And
to
use that
wrap what of Python, Theo?
The actual Python runtime. Okay, so the Python runtime is being wrapped by is being run inside VAT. Okay, and it's being run inside Node.js via this native add-on that loads the Python libraries dynamically. Okay, because of the ABI stability guarantees that they offer. Okay. So we can load them dynamically, minus a fact that we need to change a little thing in the .so file, and so we need to patch that at install time. So there is a WebAssembly script that runs and loads the code and patches it, and it loads the binary, find the right location of the Python runtime, patches it, and then rewrite it from scratch to disk. it was tricky as hell to get that right. Okay, and especially on both, it was very hard. It was really hard.
And can you explain a little bit how the then request model is going to be handled, how the communication between Node and Python happens?
So
I think it's interesting.
The runtime offer this ASGI endpoint. Okay, so there's an API that is a sink in Node.js that we can call, and you need to pass in all the HTTP request data, and you get an HTTP response back. That's it. That's what it does. Okay. On the other side, it's being run inside its own thread. Okay, Python is being run inside its own thread.
So it's in a worker thread, right?
No, it's literally it's a C++ thread. It's a C thread. It's a P thread. Like it's a UV thread underneath everything. Okay. And Python is being run there. Okay. And things are being scheduled. So the request arrives. Okay. The request arrives, and then it's been translated into the ASGI pattern, API spec, so that it's called, okay? And that's essentially what it is.
Okay. So basically, we have the main thread of VAT. We have another thread for Python. And Node that runs into the worker threads communicate through interop to the Python process.
Yes, okay. to the thread. It's in process.
Yeah.
It's in process, so that the actual request response over the overhead of sending is actually very low.
Okay. And what are the performance and the kind of like benchmarks on this solution? Like if I take a fast API, for example, application.
It's if we wrap it inside the Node.js app, okay, it's essentially as fast, is a little faster, or very close to anyway, just using fast API run, okay? Then you start adding metrics and a bunch of other things, then it slows down a little bit and so on. But it's pretty good. The performance is actually very solid. I think there is also some optimization opportunities in the future. So, and we can do more. Yeah, it's great.
And is the communication duplex, or for now it's just single?
It's just request response. So it's duplex in the sense that you request and send a response. We don't support WebSocket yet, and we do not, and we have do request response. So there's no outgoing request or API that you can use to send outgoing requests from Python outside. This is coming. Okay, we need your help to get it done.
Okay, but let's try to take a little bit of a step back for a second from the technology and go into the real life kind of like use cases. Where do you see this thing useful? Like with PHP it was easy, right? It was like the whole headless space, the whole kind of like
this is actually super easy as well. Okay, there is plenty of companies building stuff right now that are mixed Node.js and Python, and now you can run them together. And that's great. You should do that. That's it. It works.
But like, let's give a real life example to the people. Like, what do you think is a good real life example for everyone? Like, for example, having some sort of like Python that runs whatever kind of like computation.
Yes, so you have essentially, let's say you have some data science calculations that are run with pandas or something analog, okay? You can take it, wrap in your fast API system. You can take that fast API system, put it into that. You have now that thread running in the machine, okay? So you can just call it internally without even exposing it to the public, so you don't need to worry about anything. You can just expose those APIs, and there you are.
And is this thread gonna be protected by the permission and so on from Node.js, or is what are the
the thread is it's just a Python interpreter with all things that it entails, so it has access to disk and the same security model. Okay.
Yeah.
However, because the HTTP requests are fake, are governed by Node by the Node app, you can provide whatever access layer you want on top of it.
Okay. And does it also kind of like come with all the goodies that VAT is offering to the Node.js application, or there's anything missing right now? Like, for example, auto restart, for example, all the metrics and so on.
Yeah, it works automatically. It has auto restart. It works with the metrics. It just works.
Okay, so there is feature parity with running Node application, but now
there is minus
Python.
the call outside that is not supported.
Okay, and but let's take a use case that probably everyone we talked with Feroz about it. That was kind of interesting. In this new world of agents.
Wow.
And you see, OpenAI just released the agent builder. I don't know if you saw it.
Yeah, a workflow engine.
An agent builder.
Builder.
What we had 13 years ago. Now it's called an agent builder. Before it was a workflow engine, and before was called an ESB. I mean, you can call it as you want.
Yay!
Just something to build a state machine, like nothing fancy. Where do you see actually our solution fitting in that space of this agent kind of like economy? Because that's an agent for everything. There's also an agent to hack your system, as Feroz
said. Well, we should have less agents that hack systems. Yeah, less agents.
But where do you see basically Python, this solution, fit in that ecosystem? Like, is this something that you think is going to make, companies' life better? Is
like the solution? The solution here is actually relatively simple. So it's going to make the life of companies significantly better because teams can take the code snippet that they have from Python, okay, and follow the dictate of their management that all AI should be written in Python, okay, and at the same time do keep running their JavaScript if they want to, okay, and keep building delightful front ends.
So basically, you see this kind of like you see it as some sort of like catalyst, mostly to do a strangler, and to make everyone's happy, okay. And I mean, the more we work on VAT, the more I'm envisioning this future where before we had multiple runtimes, but now we have a multi-runtime engine, right?
Yay!
Where do you see that kind of like thing going? Like, I give you an example, right?
Yeah.
A long time ago, they told us that there was an infrastructure abstraction called Docker. It was making everyone's life better.
Yep.
But still, this primitive.
Keep going, Luca. Sorry for
interrupting. No, go. I mean,
so the problem. Okay, we have two problems with. So the story of the last decades has been dominated by essentially two forces. Okay, one is Kubernetes and Docker. Okay, and the other one.
Container world. The container world.
The container world. Okay, and on the other side, the often proprietary, serverless initiatives, okay? So I have on one side generic containers that run a Linux process, okay, more or less. And on the other side, I have custom built runtimes tailored for a specific infrastructure, okay, that is being spun up and spun down essentially on demand, providing a way to write very granular things, okay, together and without, but still providing some sort of isolation between them, okay.
Mm-hmm.
And I came to the conclusion that both of those patterns do not solve the problem well, okay. On one side, containers, you have the problem of if I have a horde of microservices, I cannot keep adding deployment pipelines for having individual deployment pipelines for each one of the microservices. Otherwise, my life becomes the life of my DevOps team becomes a nightmare. So if I have to manage 20 DevOps deployment pipeline, people, don't like them, right?
I heard one story once. Sorry to interrupt you. That says, "Why do I need VAT when I can actually squeeze all my microservices in different Docker layers?"
Wow. Okay. Layers. They said layers.
Well, yeah, containers, layers is the
Okay.
same. You can.
Wow. Okay. And so, it's a phenomenal, structure. So we can create multiple containers and so on, but then you want individual deployments. Okay, how can you do individual deployments with the current system? It's very hard.
Well, you could, right? You could potentially kind of like, have a pipeline with Argo CD or whatever that kind of like takes for each change to a different service, regenerates the whole container and so the whole pod. But the difficulty is that you are missing all those primitives, and then there is really no management on those individual layers because then it's done at the container level.
Yeah.
While we operate on the worker thread layer.
Yes.
Not on a kind of like virtual/physical layer. And what is kind of like interesting is that I was reading something from somebody and I'm not going to mention that this person said, no, I think this person said one thing that is that I agree, and the rest is all BS for me. What about the Kubernetes? We should actually use OpenFAS and blah, blah, blah. This one is all BS. But I think this person said something super interesting, that serverless is the best infrastructure for agents. And I think there is some truth there, because I don't think the current serverless is the perfect infrastructure for agents, but the idea of serverless is a great foundation for agents. That should be in the sentence. Clearly,
so
you will not sell their solution.
Let me clarify. So I have 2 points there. Okay. So Firecracker and the level of isolation that you can produce with Firecracker, okay, is the right abstraction for agents.
The encapsulation, yes, that
this is the thing, the only way that you can safely protect, the outside from what's running inside. Okay.
Correct.
And this is probably the only way to do it properly. So there is that. Okay.
I agree.
So, but serverless is not that. Okay.
Correct.
Serverless sits on top of that. Okay. And very often when people talk about serverless, they talk about lambdas. Okay. And unfortunately, my take on that is it's not the right primitive. Okay. Mostly because with agents, your application, okay, should be in control of how those agents execute and how much that costs to you, that execution, okay? The elastic capability of Lambdas do not allow that very much, okay?
But also,
Specifically, let me finish, Luca. Specifically because of the wait time, okay? The agents are wait for a long time, okay? So you need to be billed for the time of the actual time of execution, not the start time and the end time of the function, okay? And the billing model changed everything here. So there is that.
So two things. The first one is that there is no way to predict how those agents they will operate individually, and there is not really non-linear scalability to these agents, in my opinion, right?
Exactly.
Because if we say that agents are a workforce, we have been living for more than 2,000 years knowing workforce management, so we know exactly what it is.
It is.
But the other point is that, and I think now it makes sense why I started that conversation, was that the reason why we are building this, this multi-runtime primitive, is that we know how to scale it, and we know how to rebalance resources within those macro execution space. What you cannot do with Firecracker right now, well, you can, but with serverless, is that those execution units are atomic.
Yes.
And so that's also where Kubernetes tried to go with a vertical pod autoscaler, with many, many other things. But the problem is that they start with the concept, I know how much resources I can allocate to a specific operation. Well, what we are doing is that we dynamically can adjust the resources based on the demand, which is a completely opposite equation, because thanks to that, and that's the reason why we're adding Python, we add PHP, we are actually having this execution unit that they can signal the mastering commander, so the ICC, and say, look, I'm personally running hot. I let you decide what to do. But most of the system, they work the opposite. They say, I assume that you are hot because I got a metric that says that you are at 60% utilization. So I assume you're hot, but we don't know
super hot
how much that 40% is actually way more than 40%. And the cost is extremely high. So I think in this new economy, what we need is probably to sit down and reflect for a second and think about the humongous amount of resources that we are throwing away for the sake of saying it lowers my management. But in reality, it's because there's no solution that can really manage this horde of things altogether. And the other thing where I think Kubernetes and all the systems that you said, they lag really behind, and I personally think they are not efficient, is one single thing. All these systems, they are completely runtime unaware because they consider their primitive, the infrastructural primitive. While we believe that the runtime itself should signal the infrastructure and say, I need more resources, find a way to add more resources to what I need in my fleet. And I think that's actually the reason why for us is extremely dear to pursue this world of a multi-runtime system instead of having this atomic runtime engine. So sorry to jump into the theoretical computer science, but I think it's very important as a kind of like wrap up to our chat.
Yeah, absolutely. It's critical. Like there there is always this saying, and to use the best technology for the job. So,
and one size fits all doesn't exist.
And one size fits all doesn't exist. Okay, so and also there are personal preferences, and personal preferences should not be discarded. Most importantly, though, the actual, and then there is realities. Like if you're building for iOS, you need Swift. If you don't like it, you don't use Swift. Okay. If you use a building for Android, you develop with Kotlin. If you don't use Kotlin, you don't. Okay, that's it. Like you just don't develop for Android. Okay. If you're building for the web, you're using JavaScript. And if not, you're not building for the web. Okay?
By the way, I don't want to open a can of worms, but
we should do a session on React Native.
React Native. Because yes. I would love to invite a person
Let's do that.
Person that did the Skia thing, because the Skia engine, I think it's like a masterpiece that Google.
Let's do that.
Like another.
Let's do that.
I don't know. Google comes out with these masterpieces of engines. It's like Rolls-Royce. They make perfect these extremely powerful engines, and they cannot make a decent chassis around it. Now you know my preference with cars. Porsche on the other side makes phenomenal engine with beautiful, elegant chassis. And for the old people listening, no, Ferrari doesn't. High cost of maintenance for just a fancy car, nice car, but in my opinion, nothing beats Porsche. Anyhow, before we go into discussing cars, that is my other passion.
And pens, Luca.
And fountain pens. We are gonna see each other next week.
Yeah.
And till then, Theo, great trip, and see you next week.
Bye, Luca. Bye.